And today what we're going to do is we're going to talk a little bit about related rates, what we talked about in class today. I'm going to go over the two problems we did in class just one more time so that you have a visual if you want to watch it again. So it's going to be the Tweety Bird one and the Bugs and Daffy one. Okay, so again, what we have here is we have a situation where Tweety is resting in a birdhouse 12 feet off the ground using a 13-foot ladder. That's leaned against the pole of the birdhouse. Sylvester tries to steal the small yellow bird. Tweety's bodyguard Spike is going to try and pull the ladder away. And what's going to happen is he's pulling the ladder away at a rate of 2 feet per second. And how fast is the ladder falling when the top of the ladder is 5 feet off the ground? So in other words, let's just kind of visualize this, because a lot of times if you can visualize it initially, it's going to help with the problem. So what we have is, if you think about it, we got this bird pole, or this birdhouse that's up on a pole. And what we have is we have a ladder that's leaning against it. So let's have that ladder. And the one thing we know for certain that is like, without question, not going to change is that this ladder is 13 feet. This ladder is 13 feet. We know for a fact that that ladder is 13 feet. So now what's happening is we have two other variables that we're going to deal with in this problem. If you think about the way these two variables are, we have kind of a vertical distance away and a horizontal distance away. And to just make it easy, I'm going to call the vertical distance X. I'm going to call the horizontal the horizontal distance X, the vertical distance Y. So now what we need to do is we need to kind of figure out what's happening here. So we're pulling this ladder away. So what's happening is somebody's grabbing the bottom of this ladder and pulling it to the right. What we're actually seeing is we're seeing a rate of change. And the rate of change we're seeing is we're changing that X value and we're changing time. What we're doing is we're changing that guy at a rate of 2 feet per second. So what's happening is he's pulling the ladder, and as the ladder's getting pulled to the right, in this case, it's moving at 2 feet per second. So what happens logically is when I pull a ladder out to the right, the top of the ladder slides down. So what's happening is this thing is going down. The ladder height is going down. And what we're asking is, what happens when this ladder is 5 feet off the ground? So if you think about 5 feet off the ground, what we're saying here is that my Y height is 5 feet off the ground. So if you think about this in this context, we're dealing with a right triangle. We have a right triangle that has a two legs and it has a hypotenuse. So what we're looking at here is we're trying to find what is the change in this vertical? What is the dy dt when y is 5? So we need a formula to use. So if you think about this in terms of this, we got a right triangle. We're talking about three sides of a triangle. And what we're trying to do is we're trying to figure out more or less lengths of a triangle. So what we're actually going to be using here is we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. In this case, what I'm going to find out is x squared is my horizontal distance, my horizontal leg, y squared is my vertical leg, and that's going to equal 13 squared, which is my hypotenuse. Now, before you ask on this one, why don't we plug in the 5 for y? Because actually, if you think about it, that height, that vertical height is changing. We're looking at this instant of 5 feet. Like at that point, how fast is the ladder going? So what we have here is we have our function here, or our equation here, that we're going to now have to do an implicit differentiation of. We're trying to find a derivative with respect to t. So when I take this derivative, implicit differentiation says that this is 2x times dx dt plus 2y times dy dt, because again, we're taking our derivatives with respect to time. And this is going to equal 0. And the reason it's going to equal 0 is a derivative of a constant is always 0. So now what we have is we have an equation that we need to solve for dy dt. Well, that tells me I need to know some stuff, because I got 4 unknowns here. I got an x, I got a dx dt, I got a y, I got a dy dt. So basically, I need to know 3 of those 4. Well, from the problem, we know that y is 5. That's where it stops. So we know that this is 2 times 5. And we know that dy dt is what we're solving for, because that's what the question says. How fast is the top of the ladder falling when it's 5 feet off the ground? This is going to equal 0. So that tells me I better know x and I better know dx dt. Well, in this problem, we actually do know dx dt. dx dt is 2. What we do not initially know is we do not initially know x. What we need to know is how far is this bottom of the ladder from the bird pole at 5 feet? In other words, basically what you want to think about is this. The ladder is 13 feet long. We are now 5 feet off the ground according to the problem. We need to know this value of x. In other words, we're going to use this formula right here, x squared plus y squared equals 13 squared, and we're going to solve for x. So what I'm going to do is I'm going to say x squared plus 5 squared equals 13 squared. Now, if you know your special right triangles, you can tell me what x is here. X is 12. But if you don't, you solve it. X squared plus 25 equals 169. You subtract 25 from each side. Subtract 25. X squared equals 144. And in this case, that tells me that x is going to be 12. So it tells me that when the dog is done pulling this ladder out, when the ladder is 5 feet off the ground, it is 12 feet away from the pole at the other end. So now I can actually substitute 12 in here. And now what I'm going to do is I'm going to simplify. This becomes 48 plus 10 dy dt equals 0. Subtract 48 from both sides because I'm solving for dy dt. So that tells me 10 dy dt equals negative 48. I'm going to divide both sides by 10, and dy dt is going to equal negative 4.8. Now here's the deal. If we think about this, let's go through and realize what our measurements are in. X is our horizontal distance, and x is going to be measured in feet. Y is also as a vertical distance. It's also measured in feet. In this case, t is our time, and that's measured in seconds. So then what we have is we're figuring out dy dt. So the change in y over the change in t. So this is going to be negative 4.8 feet per second. So what that says is this thing is dropping because it's negative. What it's saying is as we're pulling the ladder away from the wall, the top of that ladder is dropping at a rate of 4.8 feet per second. So that's called a related rate problem. It uses the implicit differentiation to do it. So that was the first one we did in class. Let's talk the second one. Second one is the Bugs Bunny and Daffy Duck are dancing. And they're dancing off the stage that's covered by a spotlight covering their move. If they're moving off the stage along a straight path at a rate of 4 feet per second, and the spotlight is 20 feet away from this path, what rate is the spotlight rotating when they're 15 feet away? So again, if you think about this, this again is going to be a triangle. But let's think about this guy as an upside down triangle, or a triangle where the point is down. If we think about this, it's again our right triangle, so we're going to be dealing with either Pythagorean theorem, area of a triangle, sine, cosine, something along those lines. So what we know for a fact is when we look at this problem, we know that, again, this is going to be my x measure, this is going to be my y measure, because again, x-axis is the horizontal, y-axis is a vertical. What's happening is we know that this spotlight is 20 feet away. We know that that spotlight is 20 feet away. So again, what we're doing is we're measuring y in feet. We'll also measure x in feet. We're going to measure t is going to be time in seconds. And we're going to look and see what other kind of measures we have here. So what happens is the following. Bugs and Daffy, what they're actually doing is they're kind of moving this way. They're working their way off the stage. And as they're working their way off the stage, they're going at 4 feet per second. So their change in their x, their dx dt, is 4 feet per second. What again they're moving is they're moving across the stage to the right. The reason it's positive is because they're moving to the right, so it's 4 feet per second. So now what we're actually asking to do is we're actually trying to figure out how fast is the spotlight like moving? Because again, if we think about this, we're not asking how long this is, because that's just a distance. We're actually asking as Bugs and Daffy move this way, what's happening is this angle here is actually going to be moving as well. The angle of the spotlight is actually the speed of the spotlight, because you're starting at this fixed point 20 feet away, and it's kind of panning to the right. We want to know how fast that is. So that's going to be theta. And I'm going to tell you that theta is typically going to be measured in radians. And what we're actually trying to do is we're actually trying to find the rate of change of the angle. We're actually going to try and find d theta dt when, in this case, they're 15 feet from the path closest. So basically what we're trying to figure out is we're trying to say that as they're moving this way, they've moved 15 feet. So this is going to be when x equals 15. So now what we need to do is we need to actually try and figure out the problem. So now the problem is not a Pythagorean theorem initially, it's more of an angle issue. And what I know is I have this angle here, and I'm dealing with two different sides of the angle, or two different sides of the triangle. Excuse me, sorry. So if we look at it from the perspective of this angle, I'm looking at the opposite, I'm looking at the adjacent. So what I'm actually going to be doing is I'm going to be worrying about the tangent of an angle, because tangent is opposite over adjacent. That's x over y, right? So x is my opposite, y is my adjacent. Well, only one of those numbers is fixed. If you think about it, there's one number that stays set and it does not change at all. That's y. What I'm going to say is that tangent of y, or tangent of theta, is equal to x over 20. Because their vertical distance on the stage, Bugs and Daffy are dancing, so they're moving. The spotlight stays in one place, and we're just trying to measure how fast it's moving, like how fast that spotlight is moving to the right. And what I'm going to do is I'm going to tell you, instead of thinking of it as x over 20, I'm going to tell you to think of it as 1/20th x. So now what we're going to do is we're going to do our implicit differentiation. We are going to take the derivative of tangent theta. The derivative of tangent theta is secant squared theta. Oh, d theta dt. And we're going to take the derivative of the other side. The derivative of 1/20th x is 1/20th dx dt. And again, if we notice, in terms of substituting in numbers, we've got the dx dt. We know that that dx dt is 4, so that's going to be 1/20th times 4. Here's the problem. We need to know what secant theta is. In this case, we got to figure out secant theta. And if we know secant theta, we can figure out secant squared theta. Well, to think about the secant theta, is there a way we can figure out secant theta? Because again, when I look at this triangle, what I know is this following fact. I know that at the end of this thing, when I'm checking, we're 20 feet away here, and we've moved 15 feet. So that's where Bugs and Daffy are standing, and I'm trying to figure out that measure theta. So if you think about it, what is secant theta? How could I rewrite secant theta? Secant theta, according to the rules in trig, is 1 over cosine theta. And if I think about 1 over cosine theta, SOHCAHTOA, that tells me that secant theta is going to be 1 over cosine is adjacent over hypotenuse. So that tells me that secant of theta is going to be equal to hypotenuse over adjacent, basically the reciprocal of it. So that tells me I need to know the hypotenuse and I need to know the adjacent. Well, I know the adjacent. The adjacent is 20. This is my adjacent. I don't know the hypotenuse of this triangle, but I can figure it out using a squared plus b squared equals c squared. A squared is 20 squared plus 15 squared is going to equal c squared. And again, what I had said is if you know your special right triangles, what you're going to find out on this one is this guy, c squared, is going to be 25. I'm sorry, c squared is going to be 625. And c is going to be 25. It's actually your 3, 4, 5 triangle, but it's all multiplied by 5. So that tells me that the value of secant theta is going to be your hypotenuse 25 or your adjacent 20. If I want to make it simpler, it's 5/4. So that tells me that this value right here is going to be 5/4 the quantity squared times d theta dt. And then now I get into the algebra part of it. This becomes 25/16 d theta dt equals 1/5. 1/20th times 4. Multiply both sides by 16/25. And what that will do is that will make that go to 1. It'll leave me d theta dt. And it's going to be 16 over 125. And the units of measure, it's theta over t. It's going to be radians over seconds. So it's 16 1/25ths radian per second. So it tells me that's how fast that spotlight is moving as Bugs and Daffy are dancing across the stage. So that is the two problems we did in class. Realistically, what I had said was when we work these problems, what you really need to know is you need to know the following formulas. We're going to do this one in class next time. You need to know the area of a triangle is 1/2 base times height. You need to know the Pythagorean theorem, a squared plus b squared equals c squared. You need to know your sine theta. Your sine theta is x over r. It's y over r. My mistake. Y over r. It's your y over your r. It's your value of your y over your radius. The value of cosine theta is x over r. The value of tangent theta is y over x. You really should know those for this. You should know the circumference of a circle is 2 pi r. You should know the area of a circle is pi r squared. You should know the area of a rectangle is length times width. You should know the area of a square is side squared. You should know the volume of a box is length times width times height. You should know the volume of a cube is as s cubed. I would say those are probably the ones that if you know those, you're going to be safest. Usually if it's going to be spheres and cones and other kind of odd shapes, they're going to give you the formula, but these are ones that you really should know. So this is what we did on related rates. We're going to do more on related rates next time. So what I'd ask you to do is to try the homework problems, see what you get, what you don't. I've got the answer key up there with the steps. What I'd really encourage you to do is try it yourself. We're going to work on more of those in class and be ready to come on Monday with more questions if you have them.